In this series of videos I'm attempting to repair and restore this HP 9845B vintage computer. So far I've been through the machine, carried out quite a number of repairs. I've still got quite a few left to do, but it is now starting to boot up. I can boot the machine up, I can enter programs. The ancillaries still don't work the way they're supposed to. The printer doesn't work correctly yet, although I can now at least print something on it. The in-out system doesn't work, and currently I'm working on the tape drive. And anyone that's familiar with HP machines of this vintage will be familiar with these tapes, and in particular the issues that they can throw up. The tapes are notorious for failing, and they fail in fairly specific ways, and it's fairly common issues you get with them. And I'm going to cover quite a lot of ground in this video, so I'll be skipping through a great deal of it, but if there's anything I cover and you want more information, more details, then leave a comment and I will attempt to post a more detailed video on that aspect. The first thing with the tapes is it's not the end of the world if you have a faulty tape. You can actually quite often repair the tapes. You can also replace the tape in them. I'll come onto that later in this video. But the main thing is if you come across a tape, an old tape, and this one I haven't had out of this case yet, an old tape like this, do not try to put it into your machine and read it. You will almost certainly destroy it. And there are things you can do to minimize the risk to the tape. And I've been doing this for a while, and one of the reasons I wanted to get my hands on a 9845 is because of the way the tape drive system is arranged. It's an ideal test bed for carrying out various experiments on the tape drive system. So I want to cover some of the things I've been looking at over the years, and in particular with the 9845. So the first thing is how to minimize the risk of damaging an old tape. Now, having said you can repair these, you can't really properly repair a very old tape, but you may be able to make it readable and then transfer the contents onto a newer tape. I'll come back to that later in the video. So the first thing, we'll look at what the issues are with these old tapes. So I'll get this tape opened up. As I say, I haven't opened this one yet. I don't know what condition it's in, but almost certainly it will have the usual array of problems. So the first thing I need to do is get rid of anything on the back, because we need access to the screws underneath this label. Hopefully it will just peel off. We can use some label remover later to clean up the back. Just 4 screws that hold this in. Don't try and turn the tape at this point. If you try and turn it, what's happened, and what will have happened, is all the tape will be stuck together, and I'll explain why that occurs in a couple of minutes. But take out the 4 screws. So once we have the 4 screws out, we can take the top cover off. Try to avoid lifting anything out with it. Cover comes off, and we then have access to the inside of the tape. Okay, so with the top cover off, we can look at the internal workings of the tape drive. This one seems to be in remarkably good condition. Normally what you will find when you take the cover off is this drive belt has decayed, and almost certainly if you try and use it, it will just snap. And when it snaps, it tends to chew up the tape. It gets caught. Basically the tape sticks to this belt and it drives it round, wraps it round the wrong way, and it chews up the tape itself. At the moment, if this hasn't been turned, the tape may be recoverable, but if you do any of these tapes, then almost certainly you will need to replace the drive belt. There are other tapes that you can modify these tape drives to use, such as a DC2000. And the belt out of a DC2000 will actually fit in the DC100 if you're desperate and you have a valuable tape. but you need a drive belt. There are several alternatives. You can use things called plastibands, which is what I normally use, or you can take the belt out of a DC2000 and use that instead. Just be warned, if you take the belt out of a DC2000, it probably won't look like you expect. As soon as you relieve the tension on them, they shrivel up and it looks like it's completely destroyed, and it is quite tricky getting them back on again. But they do work in DC100s quite nicely. So the first thing, as I say, is don't try and turn this. Chances are all the tape is stuck together. The binder for these tapes tends to absorb moisture over the years. It turns it slightly sticky and it causes everything to stick together. And if you try and turn this, not only will it pull the magnetic coating off the tape backing, but it will also contaminate the rest of the tape. What you need to do is to start by baking this. So leave the top cover on, and baking is just really heating up about 50-55 degrees centigrade, so 120 to 135 Fahrenheit. Sounds like a cookery program, doesn't it? And all you do is then heat it up. Now I've made up this device. As I say, I've done quite a few of these tape drives. So this is just an aluminium block, looks like a thin sheet, but it's actually got a recess milled into it. It's about 25mm thick block of aluminium. There's no heater in this as such, this TO3 device. It's just biased with a single resistor, so the entire circuit is just this is a BDY20, it's basically 2N3055. It's biased. In this case, this particular device needed a 33k resistor. This connects the base up to positive, and it's then wired across a 12-volt supply, and that arrangement it gives you a nice ramp up. I've mentioned in previous videos that using a few components you can often get quite nice responses from very simple circuits, and what we want to do is very gently and slowly heat this up. And because of the way a bipolar transistor works, if we bias it correctly, then when it's cold it will pass a fairly low current, and as it starts to heat up, the current it's passing will start to increase, so it will ramp up the power. This arrangement, it starts off at about 6 watts, and by the time it gets up to 55 centigrade, it's up to about 30 watts, and that takes about 20-25 minutes, so quite a nice steady heat up. And then there's a temperature sensor sitting inside a recess in the block, and a simple Peltier controller, and it just controls the temperature, and we just leave it like this. The thick metal base plate on the tape tends to make the entire inside of the tape warm up, and if you leave it for maybe 12 hours, maybe as long as 24 hours at that temperature, when you come back it should have dried out the tape, and you probably find then that you can safely, fairly carefully turn it. And what I then do is replace the belt, very carefully drive it from end to end a few times, very slowly, just to make sure it's freed up. That then normally makes the tape readable, and what I do from that point on is try to replace the tape itself. So the next step for me, and I'm just saying what I normally do here, not necessarily what the best course of action is. There are alternative tape types you can use. So we've got the standard HP DC100 tape. We can modify the tape drives, which we'll look at in a few minutes, to accept DC2000 tapes. Most of the HP machines that use this type of tape and these tape drives, we can use the DC2000 tape unmodified. We do need to modify the tape drive, but the DC2000 tape would work unmodified. In the HP9845, we do need to modify the tape, because when you initialize the tape, the HP45 checks the length of the tape, and if it's too long it will throw up an error. So when you use the initialize command with a standard DC2000, you probably get an error towards the end of the process. And this is just really a matter of shortening the tape. The DC2000 is 205 feet. The DC100 is 140 feet, so you need to take about 50 or 60 feet off. It's not critical, you need to be somewhere between 140 and 155, 160 feet. Any longer than that and you'll get an error. Anything less than about 135 feet and you'll get an error. So you can modify it, and that's just simply a case of removing some tape. Now there's a slight complication when you do that. If we look at a standard DC100 tape, starting at one end, if we start working our way along it, you'll find that there's a series of holes. So we've got a small hole here, don't know if you can see that, and then if we keep going, so there's another hole there. This is the end of the tape, another single hole. The beginning of the tape has a different pattern. It's got a single hole and then 3 sets of dual holes. So if we cut the end off the tape, obviously we're going to lose this, and the DC2000 has the same arrangement of punched holes at the end. But if we just cut the end of the tape off, we lose these holes, so we need to repunch them, otherwise again we'll get errors. And repunching them is fairly straightforward. You just need to know what the hole pattern is, and it's fairly straightforward. It's not a complex pattern. So at the start of the tape, from the end of the tape, you measure 24 inches. There are then 2 holes punched fairly close together, space of 12 inches, 2 more holes punched close together, 12 inches, 2 more holes, and then 24 inches and a single hole. And then at the other end of the tape, 24 inches from the end of the tape, there's a single hole, then 12 inches, another single hole, 12 inches, another single hole, 24 inches, another single hole. So if you cut the end off the tape, then make sure you punch the right sequence for the end of tape holes. If it's the beginning, then again punch the correct sequence. I normally cut the beginning of the tape off, although it's a more complex series of holes. The tape's normally been sitting in the start of the tape, so it's been wound to the start when it was manufactured. If it's a new tape and never been used, it will have been sitting like that for a long time, so chances are the start of the tape might have some issues. So by removing the start of the tape, you get rid of the part that's most likely to cause you any problems. If it's a used tape, the tapes actually have 2 index tables for any data, and if they've been rewound and left for a long time and then they've been turned, chances are the tape will have been damaged at the beginning of the tape where the first index table is. Chances are you may, if you can recover it by baking it, you may be able to get the machine to read the second index table, and you'll see an index listing on the screen of the machine. If you can do that, you still wouldn't be able to read the tape, because as soon as it tried to wind forward, it would encounter the gaps or the clear parts of the tape, and the machine would stop. You can use a permanent marker just to cover over those. You can't recover the data that's there, but if the only damage is in the primary index table, you can mark over those with a permanent marker, and then you should be able to read the tape. But just be warned, you may only get one chance to read it, so it's best to immediately copy it directly to either an electronic form, if you've got a serial connection to the machine, or to another tape. So punching the tapes themselves is fairly straightforward. I'll show you on the DC2000 tape because it's a lot easier to see, it's a lot wider. But the process is the same for the DC100. Now I made up a few test jigs, and they are nothing more than a brass block that's split in 2 with a groove in it, and all I need to do to punch this is the jig for the narrower DC100 tape. So we put the tape into the slot, measure from the end, and just have a ruler in the appropriate place. And if we're at the end of the tape, all I need to do now is, with this loosened, I can pull the tape through. Now normally this would be on the tape reel. We'll just pull it through using the ruler to measure the length. When I've pulled it through the appropriate amount, I can push this down, it holds onto the tape, push the punch through the tape, either single or dual holes, and then release the pressure, and then I can pull it forward the appropriate amount, put it back down, punch again, and just keep doing that until I've got the correct sequence of holes punched. If you don't want to go through the trouble of making a jig like this, they are quite time consuming to make and they do need to be very precise. What you can do instead is use some a simple hole punch. There are a few available. So you could use something like this, and this is not really suitable for the DC100 because it only goes down to 2mm. But you can get specialist versions of these punches that do go down to 1mm. So I've got a few of these for different sizes. This 1mm one will work for DC 100s. The other thing to bear in mind if you're punching the tape is that the holes have to be in a location from the bottom edge of the tape that's the same distance to the center of the DC100 tape, even if you're punching the DC2000 tapes. So if you imagine the distance between the bottom edge of the DC100 tape and the center of that tape, that's how far you have to punch up, even if you're punching a DC2000 tape. Now the other thing, if you're punching these, if you just get the punch, so I'll demonstrate with this, it's easier to see. If you just get the punch and try punching, however hard you squeeze, it's almost certain you won't be able to get a clean hole because the tape is so thin that the punch, fairly cheap punches, but even the more expensive ones tend not to cleanly punch all the way through. You can try and pull the little disc out with a pair of tweezers, but chances are the tape will tear. And also, if you don't have a nice clean round hole, when the tape is put under tension, again it can tear. One thing I found that works quite well for punching this is to fit a small piece of tape to the anvil of the punch. So it just goes onto the anvil where the punch is going to press, and because it's now got this kind of soft backing, when we try and punch the tape, it's going to punch all the way through. So this time it's left a nice neat round hole, and it's taken the disc with it, and you do need to replace the label each time. It will punch through that as well, but it makes a very nice neat job, leaves a nice neat round hole, and then the tape isn't going to tear. So with the DC2000s I actually use a 2mm punch, and just it alleviates the need to be ultra precise with positioning. You can't do that with the DC100, the tape isn't wide enough, so either I'll use a 1mm punch or I'll use the die that I showed earlier. So once you've got the tape shortened, repunched, you do need to retension it. So make sure it's retensioned, then wind it from end to end a couple of times. Bear in mind the tape's not held to the reels, so don't go too far, you'll wind off the end. And you should find the tape winds on quite nice and tightly. So as I say, you can use the DC2000s. Something else you can do if you really want to is replace the tape itself. So I've taken the label off this one so you can see inside, and you can also see on this one I've replaced the drive belt. So these are plastic bands, and they're very useful to replace the original drive belts, and I generally speaking don't even attempt to drive a tape with the original belt in it. It almost certainly would destroy the tape. So the process is to bake them, remove the old drive belt, fit a new drive belt, and then very carefully run them from end to end and see what you end up with. The tape in this one is not actually original tape. You can, as I said, replace the tape fairly easily. So what I tend to do, if I have a tape I want to try and preserve and it's readable, I will copy it to something like a DC2000. I will then replace the tape in the original tape cassette, and then I'll copy it back. So if you've modified the tape drive and you changed the bias resistor to suit the higher coercivity of the DC2000, you should use type 2 cassette tape as the replacement tape. Just make sure you get it the right way round, don't put it in backwards. And if you have the original bias tape for the DC100s, then you can use normal ferric tape out of a cassette. So replacing the tape is fairly easy. You take the cassette apart, remove the pulleys, and then you can just take off the old tape and get rid of it, clean up all the pulleys, clean up all the spindles, and the next thing is to put the new tape on. Now the cassette of course doesn't have the holes punched in the end, so you will need to punch the holes. I normally start at the end of the tape, use a standard cassette. So based on the speed a cassette normally runs at, what we need is 140 feet of tape in the data cartridge. So if you work it out, it comes out at just slightly under 15 minutes of cassette time. And this is a C60 tape. Now the cassette is two-sided. You'd normally run it one way and then turn it over, so it's 30 minutes per side, which actually means that what you want is exactly half of the tape in a cassette, a 60-minute cassette. So the easiest way to measure this is to drive the cassette forward so that you have exactly the same amount showing on each of the two reels, and that way you know you've got 15 minutes on one reel and 15 minutes on the other, which is the exact amount you need for the HP cartridge. Cut the tape, you've then got, this is what's left, this is the other half I haven't used yet. The next thing you can do, put the top shell back on the cassette, have this coming out, that will hold this in place and it will kind of dispense the tape. I put this through my little jig, start pulling it through, punch it, attach it to the take-up reel on the HP cassette, wind up the excess until I've pulled it through by the correct amount for the next hole, punch the next hole, and I keep doing that until I've punched all the holes that are required at the end of the tape. I then wind the remainder of the tape onto the take-up reel of the HP cartridge, and when I get to the end of the cassette tape, I usually cut the leader off and a few more feet just because that's usually degraded a little bit and the length's not critical. I then punch the series of holes going back the other way, wind that onto the start reel of the HP, and again making sure this is not twisted and you've got the right side facing out. Get it tensioned, put the drive belt back onto the HP cartridge, reassemble it, drive it from end to end. It'll be fairly loose on here, so you need to drive it carefully from end to end a few times to tension it, get it nicely tightly wound on there, and you should find it works fine. As I say, make sure you use the right type of tape. So again, ferric tape for the standard bias of the HP drive, or if you've modified it for DC2000s, then use type 2 chrome tape. And they do seem to work extremely well. I'm still experimenting with them, so I'm not sure long term how reliable they'll be, but certainly in the short term they seem to do the job extremely nicely. And once you've copied the data off the original cartridge, replace the tape and copied it back, you've then got a nice reliable tape system. You can see it's actually a different colour, but this is the ferric type. So that's one way to deal with the tapes. There are other tape types you can use. So you've got the DC2000, DC2120s also work. These are even longer though, so again you do need to take the end off these, but they do have the same drive requirements as the DC2000, and they seem to work just fine. So that's what we can do with the tapes themselves. The next thing of course is how to modify the tape drives to use these tapes, and I've shown in the previous video how to modify the capstan to drive these tapes. One thing I didn't mention in those videos is the importance of the size of the capstan and why that is. Let's go to move the camera so you can see the HP. I just want to demonstrate something that I want to explain next. Okay, so looking at the tape drive, now most HP machines will accept the DC2000 tapes through their tape slot. Unfortunately, the 9845, there are a couple of issues that we need to deal with. Firstly, these tape drives are all the same and they all work the same way, but it's important to understand what the issue is on the HP 9845. So when we fit the tape into the drive, it clips into position and it's actually pulled into the tape drive by some kind of sprung fingers that sit behind the little notches. That's what these notches are for, and they're used to pull the tape in and kind of position it. But those springs, those strong springs that we feel pull the tape in, are not responsible for applying the pressure to the capstan. If we try and push this tape down, notice it's springy, it's bouncing up and down, but it's primarily kind of held up. If we pull it up, it will move up slightly, so it'll move up and down, and that's important that it can do that, otherwise you'll get problems and unreliability of the tape drive. The problem if we try and fit a DC2000 into this tape system, I've modified this slightly already, but I haven't gone all the way. I wanted to demonstrate this. So if we push this tape in, you can see already it's quite tight going through here, and in a standard machine you probably can't get this in here at all. As I say, I've modified this slightly already. But when we push this all the way in, it's clipped into position, but notice it won't move down. And the reason it won't move down is because it's wedged between this flap. In fact, if we move this flap, you can see it's tightly wedged. So it's wedged between this flap and the bottom of the cassette drive itself. So we'll pull this back out, and we'll move the camera back. I'll just explain what the issue is here that we need to deal with. Okay, excuse the crudity of the next sketches. But what we have is the capstan on the motor, and else the motor drives this round. Now, one thing to remember with these drives is that although the control system knows how fast the motor's spinning, it doesn't know how fast the tape is turning. It only knows how fast the tape should be turning because it thinks it knows the size of this capstan. But the way that the tape pressure or the drive wheel in the tape is pressed against this is down to that springiness we could see. There's a spring in the bottom of the, like a leaf spring in the bottom of the tape drive itself, and that sits kind of down in this sort of position. Very simple leaf spring, and the tape sits on top of that. So the metal plate on the tape cartridge is pressed up by that spring. The slots that we see in the tape itself are used, they're up here somewhere, but they're used to capture the tape. And at the bottom of the tape, just forward of the print head, there are these little ramps, and these ramps are used to accurately position the front end of the tape in the vertical position. And then the fingers, the sprung fingers that you feel pull the tape into the drive, sit up through here, and they pull the tape in and position it all the way in. But the tape is free, it's held here, but it's free to do this, and it's pushed up about this point by the leaf spring. And because it's pivoting on this ramp, it's pivoting around this point, so it pivots here. And because it's been pushed up, that action pushes this drive roller against the capstan. So it's actually this spring that pushes the drive wheel in the tape against the capstan, and this kind of rocking motion. So imagine this is fixed. So this rocking motion is going to push this drive wheel that's inside the cassette against the capstan. So it's actually this spring that's doing the loading up, if you like, of the capstan. So it's fairly important that the capstan's the right diameter, because if it's too big, then it's going to cause the cassette to be pushed down like this, and that can put excessive force on the capstan. If it's too small, there is the tape runs in a slot, so this plate actually runs in a slot, and if the tape has to go too far up because the capstan is too small, then the tape could kind of bottom out or top out on that slot before there is sufficient pressure on the capstan. So this needs to be a suitable size, and also it needs to be a suitable size to make sure the tape speed is correct. As I say, the motor speed will be whatever it's supposed to be because it's got an encoder disc on the motor, but if the capstan's the wrong size, the tape could end up running at the wrong speed. It's quite a lot of scope for variance, but you do need to be reasonably close, otherwise you'll get strange errors cropping up. Now this is fine with the small DC100 tapes because there's plenty of room in that access door system, but the problem with the DC2000 tapes is because they're taller, they get caught, and the tape, let's assume the tape is this tall, they're getting caught on the door. So what's holding the tape in place is the door, and it's been pushed all the way down to the base plate of the drive, so it can't spring up using this spring. This spring is fully compressed because this is being pushed down by the opening on the HP9845 door system. So we need some way to get around this. You can kind of get it to work if you put it in and jiggle this around. You can get it to work, kind of, but a better solution is to effectively lower the base of the cassette drive. So I'll take the cassette drive out of the HP and we'll have a look at it, and I'll show you how I go about modifying it to allow DC2000 tapes to fit into the 9845 tape drive system. I've taken the 4 screws out that hold the tape drive into the machine. This will now just lift out. So the first thing we want to change, and you don't strictly speaking need to do this, but it does tend to work better if you do, is this underside, this leading edge of the front flap. You can see already I've removed some material, and I'm going to remove a bit more. You can't see this from the outside, but if you take about 0.5 millimeter off here, it gives you a lot more opening. It allows this to sit at a steeper angle, and we're going to be moving the tape drive down this way, this is upside down, so it's going to be moving this way, and that means that this will move further down and it will allow the entire door system to open further. The other thing we want to do is, if you look at this other flap, and it's quite hard to see, if I get an Allen key and put it on here, then as this opens, notice the Allen key is moving up. Hopefully you can see that. And that's because the back edge of this door is of course behind the hinge point. So it's actually moving this way. Now it's fine for a DC100 tape because it's about 3 millimeters of a gap between this door and the top of the tape, which is obviously normally sitting here. So the tape normally sits in about this position, sticking further out, so it will normally sit about there, and that means that the tape, and a DC2000 in particular, is being pushed down this way by the back edge of this flap. So again, all you need to do is take off the corner. You don't need to shorten the door or take anything off that's visible, just take the very corner off this door. So again, if we just do a quick sketch. So a before and after, so with the door open, this corner, so the pivot's kind of about here, which means that this portion of the door moves upwards, and all we need to do is take off this section so it looks like this. It's not very much, it's 0.5 millimeter maybe of material. It's not visible from the outside, and that will again give us about another 0.5 millimeter of clearance. Now the tape will go in if you don't do that, so this is just giving us more scope for adjustment, and also gives the tape more of a chance to align itself correctly onto the capstan to give the right pressure. The other thing you can do is you can lower the front of the entire tape mechanism by putting a washer underneath each of these two screws. So these are 3/4 mil thick washers, and that will effectively lower, again it's upside down so it will tend to bring this up a little bit, and that will effectively lower this front edge of the tape. Let's move the camera back across. So the capstan's already been modified, and I showed how to do that in an earlier video, and it's the same diameter it was originally, 10.4 millimeters, but it is now taller to allow driving of the DC2000 tapes. But what we want to do is lower this drive mechanism. I don't want to modify the machine, and I don't want to modify this bracket or the tape drive itself. But the tape drive is positioned using these standoffs. There are two aluminium standoffs at the front, you can just see them side on there, and there are two at the back, these two taller ones, and they are what determine the overall height of the tape drive. So what I've done is machined up a replacement set. The only difference is these are 1 millimeter shorter, so I've already done the other tape the tape drive in this machine. Put them side by side. You probably can't tell, but the original on the left is 1 millimeter taller than the new one on the right, and I've done the same thing with the two shorter standoffs. So machined a new set. Now I could of course have just machined down the originals, but I might want to return it to standard at some point in the future, so I decided to keep the originals and machine a new set instead. So I'll just get these swapped out. It's just a case of taking the 4 screws out. The old ones are in rubber grommets, we'll just slide out, put the new ones in. The only other thing you might need to do, because these screws are in blind holes in the plastic housing of the cassette drive, you might need to shorten these screws very slightly, but you'll know that if you screw them in and they bottom out, then just shorten them a little bit. So I'll get these swapped out, and then that drive should be ready to refit. I've replaced the standoffs, and as I say, that has the effect of reducing the height of the cassette by about 1 millimeter, so it effectively brings the bottom of the cassette lower relative to the top of the opening, and that allows the tapes more scope to move up. As before, they're wedged hard against the door opening, and it pushes them hard down and it can't properly align itself. So I'll get this refitted to the machine and see if it actually works. Okay, I've got the drive refitted to the machine. We'll start off by trying a DC100 tape to make sure it still fits in, and it does. And now we'll try a DC2000 tape. Now normally these are a very tight fit if you don't modify the machine, but as you can see it slides in quite nicely and freely, but also we've got the spring back that we were missing before. It's not now wedged hard up against the top of the opening, and that fits in there quite nicely. And so the next thing we'll do is we'll try driving this. I'll power up the machine and see if we can successfully initialize the tape. Excuse the odd angle of the camera, it's just the way the machine's sitting on the bench at the moment. Just turn the light out so you can see the screen of the HP better. We'll get it powered up. Wait for it to come to life. Now I've got a DC2000 tape fitted that should have some information on it. So we'll try and retrieve that, try and get the directory listing. And as you can see, it has indeed worked. Let's turn the light back on and lower the camera a little bit. So this is a DC2000 tape. It now fits into the machine quite nicely. It will still accept DC100 tapes, and with the resistor value I've chosen for the BIOS, it will actually read and write both DC100s and DC2000 tapes quite nicely. If you want to, because the DC2000 tapes are taller than a DC100, you can fit a small microswitch that detects the DC2000, and you can use that to switching the extra resistor that's required to alter the bias for the DC2000, so you can automate switching between the two. But the DC2000s now fit quite nicely into the drive. There's no need to kind of force them in. There's plenty of movement and scope for the tape to not be pushed too hard down or forced too far up, and of course we can successfully read them. So as you see, it works fine and it's reliable. I've done the same thing with the second tape drive. This machine has two tape drives. I've done the same modification on both of them and both now work fine. So that's how I go about repairing the tapes on these. As I say, you can swap the tape. I'll just move the camera back. So as you can see, there's a lot we can do with the tapes out of these machines, but the main thing, as I said, if you find one that hasn't been used for a long time, don't put it in the machine. Don't try and turn it. You probably find if you try and turn it by hand, it's quite stiff, and then suddenly it will move, and probably you've torn some of the magnetic material off the tape. Give them a bake at 50-55 degrees centigrade for maybe at least 12 hours. Let them cool down. That normally frees them up, but even then it's best to change the drive belt before you try and run them. And that normally allows you to get at least some of the data off them. I'm still experimenting with these and looking at alternate tape types and different types of cassette material to replace the tapes with. But I've had quite a lot of success replacing the tapes in the original DC100, and they do seem to be reliable once you've done it. It's just making sure you punch the holes in the right place and use a suitable type of tape depending on how your machine is set up. But hopefully you found this interesting. If there's any aspect of this you want me to go over in more detail, then please leave a comment.